Hey, it's Mr. Hayashi this is 2.1 part 2, just going over some examples of inequalities. So with example problems, if you're given a word sentence or a word problem, you want to look for keywords to be able to figure out exactly what inequality to write. So for the first few examples, it says write the sentence as an inequality and just take it part by part. So if I take a look, it says 12 is greater than or equal to 5 times a number n. There's a couple of different ways I could write it. If I want to put the variable on the left side, it says 5 times the number n. I'm just looking for keywords there. 5 times the number n would just be 5n. And if 12 is greater than or equal to that, the opposite of greater than or equal to, since I put the variable on the left, is less than or equal to. And then that would be less than or equal to 12. Some of you might start off and write it like this. 12 is greater than or equal to 5 times the number n. That's actually the exact same inequality as this. For me, at least, it just kind of looks a little bit neater and makes more sense if the variable is on the left, especially once we start solving them and then graphing them. It's going to be easier for a lot of people to put the variable on the left. Okay, on example 2, 1/3 of a number h. So 1/3 of a number h, 1/3 of means multiplication. So 1/3 h is less than. So strictly less than, that's the inequality for less than 15. And all we're doing right now is writing the inequality for the given sentence. We're not solving it. We're not graphing it. There's another way that you could write it as well. If some of you are wondering or thinking, well, 1/3 of h, that's the same as h divided by 3. That's still 1/3 of h. It's less than 15. Really, no way is more correct than the other. Okay, and then for example 3, 7 is less than or equal to the difference of a number q and 6. So maybe start off just by looking at the sentence from left to right. 7 is less than or equal to the difference. So difference means subtraction. You have to be subtracting 2 items. So I'm not going to put just subtraction at the beginning or a negative, but the difference of a number q. Since a number q is mentioned first, that's what you're subtracting from. And then and 6, so minus 6. Okay, if you want to put it with the variable on the left side, I take everything that's on the right side. So another way I could write it is q minus 6, but instead of q minus 6, and then the inequality being less than or equal to, q minus 6 is actually greater than or equal to 7. Both of these inequalities represent the same thing. Okay, whether you write it like this or you write it like this, sometimes you just might want to pay attention to directions, and it might say specifically write the variable on the left side of the inequality or sometimes equation once we're dealing with those. All right, on the next set of problems, sorry about skipping the numbers here. More important thing is doing it basically each type of example, not the problem numbers. Like if you notice there's no number 4, but it says tell whether the value is a solution to the inequality. So here's my inequality, d minus 7 is less than 12. And then really what you want to do is figure out if d is equal to 19 is a solution to this inequality. So you could substitute. I could plug in other words, 19 for d. So I want to check if 19 minus 7, since d equals 19, is the possible solution that we want to figure out if it's a solution to the inequality, if that's less than 12. So 19 minus 7 is 12. Is 12 less than 12? It's actually not. So no, 19 is not a solution. 12 is less than or equal to 12, but that's not part of the inequality. So that's what you do for that type of problem. Okay. And then on number 7, again, we're kind of just skipping around here. Kind of like on part 1, I want to graph the inequality. Since the inequality has an equal to sign underneath it, I do want to make a filled in circle, but if I read this just from left to right, x is greater than or equal to 3. So I want to go out to 3 on my number line. X is greater than or equal to 3. So I'm putting a filled in circle at 3. X is greater than or equal to, all the numbers to the right of 3 are greater than or equal to 3. Or if you remember the little tip that we could use from part 1, the variable is on the left here. So the inequality, if you look at the inequality, I'm going to draw it in a little bit darker, points to the right, which means that's where my arrow goes. It's greater than or equal to, but the key part there is the arrow for the inequality points to the right. And then I know the directions aren't given for 12 and 13. I didn't cut and paste that part. Basically, I want to write an inequality for the given graph. So on number 12, for example, it doesn't matter what variable you use, but you have to be using a variable. I'm just going to use x. X is kind of like the most common variable that you could use. If you use t, that's fine. If you want to use p, that's fine. Certain variables you want to avoid, though. You don't want to use o for what I would say are obvious reasons. But x, I have an open circle, if you can see that, at 0. So what that means is my inequality will not include a line underneath it. And then I notice everything is filled in to the left. So everything's just less than 0. X is less than 0 would be the correct inequality for the graph. And then number 13, again, I'm going to use x. I could use y if I want to. There's a filled in circle at -3. That means -3 is included. I'm kind of just planning ahead before I figure out the inequality to use. It's going to have an equal to sign underneath it. And then everything is filled in to the right. All those numbers are greater than or could be equal to -3, which would be the correct inequality for that graph.